Thank you. Hello, everybody. Today, I will speak about how gamification impacts physics, because we think that physics is one of the fundamental school subjects in preparing students for challenges of 21st century. And this makes improving students' learning outcomes in physics essential to modern education. So let's start. For introduction, I will just say that students' difficulties in learning physics concepts are frequently caused by preconceived ideas that can be described as misconceptions, alternative conceptions, or mental models. These intuitive beliefs of students about physical phenomena are derived from inadequately understood everyday experience. We can say it like that. They are usually not aligned with models accepted by the scientific community and are very resilient to change. That is very big. That is very big problem for us in education, especially in primary and secondary education. So when we speak about gamification and its elements, the concept of gamification is broad and complex, but based on the existing papers, we can say that the general definition which is accepted is the use of game elements in non-game content. The main idea of gamification is using game strategies, game mechanics, and aesthetics to motivate and engage participants. In the sense, the gamification stands in contrast to game-based learning, GBL, which complements traditional teaching with the use of technology. I could say it that way. We also differentiate from the concept of serious games, which focuses on making simulations of the real world. Uh, uh, if we watch gamification through an educational lenses, uh, gamification can be integrated into learning process through the traditional game mechanic elements such as badges, points, rankings. You can see it here, levels, rewards. And by adopting these game elements in context that is typically not considered entertaining, we can make the educational process much more exciting and dynamic for the students. And when we speak about the frameworks that systemize elements of gamification, we can speak about Fui Hun's 5 basic principles. He describes these basic principles of gamification, namely as goal orientation, success or achievement, encouragement, competition, and fun orientation. In the other hand, we have also 7 categories of Jane McGonigal in her book of Super Better. She states basic principles of gamification through 7 categories. In example, she calls them 7 rules to live by. And those are challenge yourself, collect and activate power-ups, find and battle the bad guys, seek out and complete quests, recruit your allies, adopt a secret identity, and go for an epic win. And the last that we put on our presentation, and it is very important for us, is choose Octalysis framework, and it's 8 core drives. Chu constructed complete framework to analyze every successful game, and it appeals to certain core drives within us that motivates a variety of our decisions and activities. The framework is called Octalysis, based on the 8 core drives. They are represented as epic meaning and calling, development and accomplishment, improvement of creativity, ownership and possession, social influence, scarcity and impatience, and curiosity, and loss and avoidance. And in each of these core drives we associate with a large set of specific gaming strategies. We use this octolysis framework for our further research. In this research, we only wanted to see what is there and what is yet to come. I can say it this way. So the quest and objectives of our research, first of all, the aim of this research is to conduct a systematic review of studies that have delivered methodology of gamification in physics education based on established criteria. These criteriums, for this purpose, we seek to answer the following research questions. And research question number 1 is, what is the time distribution of studies investigated the application of gamification in physics education? Research question 2, what are the most commonly used elements of gamification in selected studies? And research question 3, what are the advantages and disadvantages of the application of gamification in these studies? And these research questions were created in order to establish the known potentials and pitfalls in implementing gamification elements in physics education, and to identify the most successful application, if any, is in this field. So the methodology we used here, our review of the published articles was guided by the PRISMA protocol and recommendations for the systematic literature review. We searched 2 large databases of scientific materials, Web of Science, WOS, and Scopus. And we analyzed all available materials in both databases, which means articles published from 1950 to 2021. We did not set the lower limit of the search time interval. However, as a term, gamification oriented in the digital media industry and became widespread and accepted only in the second half of 2010. Yeah. At that time, thanks to the development of the internet and the DICE conference via video, the term gamification went viral. The search strings we used to characterize the study of gamification in physics education were gamification and physics and school. And we applied the search through the title, abstract, and keywords. To select the documents applicable for our review, we have defined in advance the following criteria and exclusion sequence. First criterion regarding language, we took only the studies written in English. Criterion 2, regarding the format, we exclude papers on websites, blogs, and newspaper articles, as well as part of books. Criterion 3, regarding the research area, we have eliminated studies that are focused on socio-educational programs in informal contexts, such as public health. And criterion 4, regarding the research question, the documents that did not include elements of gamification in the context of physics education were also excluded. Also, those in which gamification was equated with GBL or serious games. And believe me, there were a lot of papers that equated gamification with GBL. In this table, which is presented here, are results and of our search. Searching by strings, we singled out 114 research articles. Applying the first three criteria resulted in the list of 22 articles, and the subsequent endnote comparison eliminated 4 additional papers as duplicates. The resulting 18 papers were analyzed through criterion 4, resulting in the selection of 7 full text articles that met all of our criterion. And you can see in this table these 7 articles. They are not named by author, but you can find it in full paper, which will be published in conference proceedings. You can see also education level, university, high school, graduated. You can see year of publishing, and you can see 2 main elements, gamification elements and results. Gamification elements indicate what elements of gamification are used in these articles, and results can be positive, negative, or equal. There is nothing to say if they are equal, nothing changed. The first characteristic of the selected papers that stands out is that all of them, you can see, were published within the last 2 years. While our research, I must once more say, spanned the period starting from 1950. And this indicates that the gamification application in the realm of physical education is a very novel endeavor. This table also presents the gamification elements used in each of the analyzed studies. And if we compare these elements with the Octalysis framework, we find that utilized elements largely target only a small number of the core drives from Octalysis, in particular drive 2, development and accomplishment, and drive 3, empowerment of creativity and feedback. And this narrows band purely leaves a board space for incorporating a much larger range of motivational venues in developing gamified teaching strategies. This is a field that is not researched and it is not used. We also considered the results of the analyzed studies positive. In their report, improved academic achievement and engagement and/or motivation due to the gamification elements incorporated in the teaching process. And we found that all of the analyzed studies showed that gamification had positive effects on the outcomes of students' learning and motivation. I think that is one very important result. Also, research further shows that gamification strategies combined with the elements of augmented, for example, virtual reality, can additionally contribute to the formation and development of students' cognitive interest and motivate their self-educational activities. If we watch in general, the results of our findings suggest that gamification can and does have significant positive effect on students' motivation, engagement, and academic success. And for conclusion of this presentation of our work, I can say that gamification elements can be implemented as triggers of motivation, engagement, and academic success of physical learners. The concept of gamification is frequently mistaken, and that is very important to say, with the notation of GBL and serious games. And to maximize the positive aspect of each of these different activities, they should be clearly delineated in educational practice and in research. You have lots of papers that are still they are equating GBL and gamification, or serious games and gamification, and They are not the same. Also, gamification elements have a great promise in guiding the development of new physics education strategies, both by teachers and curriculum developers. And for the final, optimizing the best gamification practices is a broad area of possible new advancements and an uncharted new frontier for the physics education research community. And for this reason, we have started one big project implementing gamification in secondary education in Croatia, in Split, Dalmatia County. So for the maybe next conference, we will have new results, and I think they will be great. So this is our presentation, and our work will be continued. And if you have any questions, thank you for listening. And if you have any questions, we are now on your disposal. Thank you.